All right, so here we go with the Mod 16 group test. Remember, your individual test is tomorrow. This is a 50-point test. Starting off with expanding. Now, I have an 8, I have an A, and I have a radical B. All three of those things are connected by multiplication. So I'm going to start off by expanding them to addition, because multiplication expands to addition. So I have log base 2 of 8 plus log base 2 of A plus log base 2. Now, I'm not going to call that radical b. I'm going to change that radical to an exponent, so that becomes b to the 1/2. So in my next step, I need to see what I can simplify. Whenever you have logs with numbers, always see if you can simplify those. This one can become log base 2 of 2 cubed. And if we remember our matchy-matchy rule, our answer here just becomes 3. So this whole first log just becomes 3, because log base 2 of 8 is equal to 3. Then I have plus log base 2 of A, and then this exponent I'm going to have to bump back in front, so I get 1/2 log base 2 of B, and that's what I'm going to write on my answer line. 3 plus log base 2 of A plus 1/2 log base 2 of B. Now, I can't stress it enough that you need to be very clear with whatever you're writing. If it is a base, it needs to be smaller and towards the bottom, and it looks like a base. Please note, this A is not an exponent. This B is not an exponent. Some people are getting in the habit of trying to write the number that comes after the base as an exponent, and that's not the way it works with logs. These are regular size. You may have an exponent on it, but you have to have that regular size number before you get there. Okay? All right, these guys. Now, I did mention a little trick in class that if something is on top, it's going to come after a plus sign, and if something is on bottom, it's going to come after a minus sign, because of that whole division thing. So if I keep that in mind, if I do log base 3 of 6, then I have a plus sign for the log base 3 of x squared because it's on top. Now I'm coming up to the y, so that's on bottom. I'm going to put a minus log base 3 of y. And then the w squared is also on the bottom, so I'm going to give minus log base 2 of w squared. Now, I do have numbers, so I need to check. Does that become something nice, like the 2 did before? And it doesn't, because 6 is not 3 to the second power. So that just has to stay. Log base 3 of 6. This guy, I got to bump that in front, plus log base 3 of x minus log base 2 of y. Again, x, 6, y, w, not exponents, so please write them regular size. And then I have 2 log base 2 of w. And I think that's my final answer. Everything, every number or letter has its own log, so we are fully expanded. So I'm going to write log base 3 of 6 plus log base 3 of x minus log base 2 of y minus 2 log base 2 of w. Okay? All right, moving on to the condensed problems. Remember, when you're condensing, the first thing you want to do is find any exponents that need to be bumped back to not being exponents anymore. So I have a 1/4 that's got to be bumped back and a 5 that's got to be bumped back. So when I bump back the 1/4, I get ln, which stands for natural log, of 16 to the 1/4 power. Oh, hold on just a second. Okay. Minus ln of 2 to the 5th. Now, what is 16 to the 1/4 power? I can figure that out on my calculator if I don't know it off the top of my head. But 16 to the 1/4 is equal to 2. So I really have the natural log of 2 minus the natural log of 2 to the 5th is 32. And subtraction would condense to division, so that gives me the natural log of 2 over 32. And I can reduce that. 2 over 32 becomes 1 over 16. So my final answer is the natural log of 1 over 16. Keep in mind, it does say write as a single log. So when I'm down to 1 log, that's when I've condensed it. Okay? Again, if you have a fraction here, make sure you're reducing it. All right, next one, exponents, got to go back. Exponents, got to go back. Exponents, got to go back. And anything that's after a minus sign goes on the bottom, after a plus sign goes on the top. So log base 7 of x to the 5th plus log base 7 of 9 squared minus log base 7 of y plus log base 7 of w to the 4th. So this guy's going to go on the top because technically that's positive, so that's a plus sign. That guy's going to go on the top. That guy's going to go on the bottom because it's after a minus, and that guy's going to go on the top. So I'm going to have log base 7 of x to the 5th times 9 squared is 81 times w to the 4th. All that goes on the top. This is the only guy that goes on the bottom. All right, so let's see if I can write that a little bit nicer in my answer. I've got log base 7 of 81 x to the 5th w to the 4th over y. And that's what my answer should look like. Okay. All right. Evaluate each logarithm. Notice these are only 1 point each. There's not much to do here. These are my matchy-matchy rules. If your base matches, if you have a log in your exponent and the base of the power matches the base of that exponent, no base is written, which means it's automatically base 10. So I have matchy-matchy. That number is my answer. Okay. There were some people who thought about this slightly different, and they said 10, well, let's see, log 100 is 2, so they just replaced log 100 with what it equaled, and then 10 squared is 100. That's another way you can think about it. But you don't need to do a whole lot of work if you remember that matchy-matchy rule. All right, this is the other matchy-matchy rule. See my matchy-matchy? My answer is just 4. Okay? All right, number of bears in a certain region is decreasing at a rate of 1.7% per year. The current population is 800 and the population after 2 years. Oh, good, they gave me an equation. So I'm going to use that equation. And I want to find out how long before the number of bears is equal to 400. So I want to know, when does 400 equal 800 times 1 minus 0.017 to the t? Well, first thing I can do is I can actually do 1 minus 0.017. Oops, don't need that that parentheses. And I get 0.983 to the t. Now I can divide both sides by 800, and I get, let's see, I'm going to come over here so I have a little more room. 0.5 equals 0.983 to the t power. And I need to go to log form. It's easiest to go to log when your exponent's on the left. So 0.983 to the t equals 0.5. So my log is log base 0.983 of 0.5 equals t. From here, if you remember from the notes yesterday, we have to use our change of base. So I'm going to plug into my calculator log of 0.5 divided by log of 0.983, and that's going to give me my time. So log of 0.5 divided by log of 0.983, I get 40.42. So again, I'm talking about years. So it looks like it's going to take about 40 years. Let's see what it says to round off to. It says round to the nearest year. So 40.4, that rounds down to 40 years. If that was 40.5 or 40 point anything higher than 5, it would round to 41 years. Okay? So in 40 years, the population will go from 800 down to 400. Okay? That's a 4-point question. All right, turning to the back side, we get into our solving the equations ones. So we're going to try and use the matching bases here because I know that 64 and 1/4 are both powers of 4. 64 is 4 to the 3rd to the x plus 1, and 1/4 is 4 to the negative 1st to the 3/2 x. So now that I have matching bases, I have 3 times x plus 1 equals negative 3/2 x. So I'm going to go ahead and distribute. 3 times x is 3x. 3 times 1 is 3 equals negative 3/2 x. So I need to get my x's together, so I'm going to go ahead and subtract 3x and see where that leaves us. Now, I have a fraction minus a number. Go ahead and use your calculator to your advantage. I'm going to write my answer up here because I'm running out of room. I still have 3 on this side. Let's see, on my calculator, negative 3 fraction 2, that's negative 3/2, minus 3 gives me negative 4.5. I don't like negative 4.5, I want an improper fraction, so I hit second and my fraction button. I've got negative 9/2, so I have negative 9/2 x. Now what do I have to do? Multiply by the reciprocal, which is negative 2/9. Over here, negative 2/9, right? And x equals negative 2/9, negative 2 over 9, times 3, and I get negative 2/3. Now, you could have totally, at this point, gone to decimal if you wanted to also, because it does say you can round to the nearest thousandth. So if I had gone to decimal, I would have had negative 3/2. Change that to a decimal. Oops, sorry. Let me change that to a decimal. It's negative 1.5. Minus 3 is negative 4.5. So I really have, if I went decimal here, 3 equals negative 4.5x. I can divide by negative 4.5 and completely avoid the whole fraction situation. And 3 divided by negative 4.5 still gets me that 2/3, but it is as a decimal. So if I wrote it as a decimal, I would say negative 0.667 because I do want those 3 digits past the decimal. So either one of these answers are correct. You do not need to give me both. All right? All right, next one. Let's see, I see my exponent term right there. I got to get it by itself, though. So I'm going to start off by subtracting 2.1. Looks like we're going to be dealing with decimals here. So I have negative 5 e to the 4c is equal to negative 15.9 minus 2.1. That gives me negative, did I do that right? Negative 18. It does. Now I'm going to divide by negative 5. So e to the 4c is equal to negative 18 divided by negative 5 is 3.6. Okay, now I'm going to convert to log form. Log form would be log base e of 3.6 is equal to 4c. We do not write log base e though. We say ln of 3.6. We don't write this log base e. That means ln. So ln of 3.6 is equal to 4c. I would divide by 4 to get what c equals. So I can just type in, notice it's ln of 3.6 divided by 4, not ln of 3.6 divided by ln of 4. And it's not the same as ln of 3.6 over 4. That's not what we're doing. We're doing the natural log of 3.6, finding out what that is, and then dividing it by 4. And I'm going to have to round that off. I get 0.320. Again, I want 3 digits past the decimal there. Okay. Moving on to the next one. Now this one, I had some people that were doing stuff over here and totally neglected that poor little 6 right there. This is one of the ones where I have to do some condensing first. So when I condense this, this gives me log base 2 of x plus 2 times x minus 10 equals 6. And once I have it condensed, then I have to go to exponential form. Exponential form means I have 2 to the 6th power equals x plus 2 x minus 10. What is 2 to the 6th power? 2 to the 6th is 64. And then I got to do some multiplying here. I have x squared minus 10x plus 2x minus 20. I'm going to move the 64 over. And if it's okay with you, I'm going to go ahead and combine my like terms there also. So I end up with 0 equals, because my 64 disappeared, I have x squared minus 8x minus 84. Now I have to factor. Now you can snowflake, you can do magic X, you can do guess and check, whatever it is that you choose to use. Negative 84 and negative 8. Let's see. Negative 84. Well, 84 does it divide by 8? Nope. 84 divided by 12. 12 and 7, not going to get me 8. How about 6? 6 and 14, there we go. And the 14 has to be negative. So, I have x plus 6 and x minus 14. And from here, I get an answer of x equals negative 6. And from here, I get an answer of x equals positive 14. Now, this is one of those ones that I have to check because I have logs in the problem. So if I plug in negative 6 plus 2 is a negative number. It's negative 4. So I have to drop that guy out. It's giving me a negative. I can't do that. What about 14? 14 plus 2 is 16. That's good. 14 minus 10 is 4. So let's see. Log base 2 of 16 plus log base 2 of 4. Does that equal 6? So far we're good because we got the positives. If I were to condense those, what is 16 times 4? 64. Does log base 2 of 64 equal 6? Well, I can use my change of base if I want to. Log of 64 divided by log of 2. Yes, it does equal 6. So x equals 14 is my only valid answer there. Again, negative 6 doesn't work because negative 6 plus 2 is negative 4, and I can't do a log of a negative number. Okay. I also can't do the log of 0, and I think that came up on an assignment the other day, but log of 0 also does not exist. Only numbers 1 and higher. Okay. Or I should say greater than 0, because you can't have less than 1. All right. Last one. I got to get my log by itself, so I'm going to subtract 5. That gives me 2 log base 5 of 8 minus 9x is equal to 6. Then I'm going to divide by 2. So I have log base 5 of 8 minus 9x equals 3. Now I got to go to exponential form. When I turn this into exponential form, my base is 5, my exponent is 3, equals 8 minus 9x. Well, 5 to the third is 125. So I can subtract 8. 125 minus 8 is 117. I can divide by negative 9. And I get x equals 117 divided by negative 9 is negative 13. Now let's check that. Because a negative number sometimes doesn't work, but I think this one's going to be okay. 8 minus 9 times negative 13, because even though I'm plugging in a negative number, because of the way that's situated, it ends up being positive. So let's check this. Does 5 plus 2 log base 5 of 125 equal 11? Well, 5 plus 2 log base 5 of 125 is 3. And 5 plus 6 does equal 11. So that does check out, even though I have a negative number. Okay? All right, last two problems. Find the inverse. We did these yesterday. We have 4 steps. Step 1, we have to change g of x to y. So I'm going to say log base 7 of x plus 1 minus 3 equals y. Now, if you remember, I said specifically if there's a log in your problem, the inverse is not a log. So if you have a log written there, that is not correct. You have to have an exponential. This one is an exponential, so I do expect to see a log in your answer because they are inverses of each other. So I changed that to y. Now I'm going to get x by itself, so I'm going to start off by adding 3. So log base 7 of x plus 1 equals y plus 3. Now I go to exponential form to break out that x. So the base is 7. The exponent is y plus 3 equals x plus 1. Now I'm going to move the 1. So I have 7 to the y plus 3 minus 1 equals x. Again, be very clear about what's an exponent and what's not. Next step I have to do is I have to change my x's and y's. So I have 7 to the x plus 3 minus 1 equals y. And then the last step is I change that y to the inverse notation. So in your answer here, I do want to see the inverse notation. Okay? Don't just write 7 to the x plus 3 minus 1. Tell me what it's equal to. Make sure to write that there as well. The rest of this would be 7 to the x plus 3 minus 1. Okay? Next one is an f of x. So my answer is going to be f inverse is equal to, and then we'll figure it out. Okay? So I'm going to start off changing this to a y equals 3 to the x plus 2 minus 4. Now I need to get x by itself, so I'm going to add 4. That gives me y plus 4 equals 3 to the x plus 2. Now I'm going to have to go to log form to get that x out of the exponent. In order to do that, it's easier usually if you move that exponent to the left. So I'm going to flip it all around here. Now I have log base 3 of y plus 4. Now since I'm taking the log of that whole thing, make sure you got those parentheses. Equals x plus 2. Now I'm going to subtract 2. So I have log base 3 of y plus 4 minus 2 equals x. Now I changed my x's to y's. So log base 3 of x plus 4 minus 2 equals y. And then my y changes to that notation I talked about earlier. So the inverse of f of x is equal to log base 3 of x plus 4 minus 2. And yes, it is important that those parentheses are there. If you did not put parentheses there, you might be tempted to do the 4 minus 2, and that's not where we're going. So make sure if you're taking the log of that whole thing, you've got those parentheses there. Okay? All right, I think we are set. Just in case you want to go back and study, these inverses, these were from lesson 16.2c. You can look up those notes or that video. These problems here are kind of a mixture. They're from 16.2a and 16.2b is where we solved all that stuff. Okay. On the front side, expand and condense, those were from 16.1a and b. And I believe, let's see, this one was from yesterday as well, so 16.2c. These ones for 16.1a, 16.1b, and evaluate each log. Let me find that really quick. Those are from 16.1c along with the change of base stuff. So if you need to see those, 16.1a is the expand, 16.1b is condense, 16.1c is these rules right here, as well as all of our change of base stuff we use on the back. This was 16.2c, 16.2a and b is that chunk, and then again 16.2c there. So there are notes and videos for all of those, all right? Happy studying.